everyone, we are Group 1 and in this video we're conducting a DIY experiment about Reynolds number.
Assalamualaikum and hi everyone. I am TJ21011 Saifullah bin Abdul Aziz and I will present about the objective of this DIY project. The objective of this DIY project is to determine the Reynolds number for a various flow condition including laminar flow, turbulent flow and transitional flow conditions. Alright, for the introduction, I will explain about the Reynolds number and the characteristic of flows. So Reynolds number is defined as the ratio of fluid's momentum force to viscous shear force. Flow having large Reynolds number tend to be turbulent, typically due to high velocity and/or low viscosity. On the other hand, fluids with high velocity and/or velocity will have low Reynolds number and tend to be laminar. So on the yellow box, there is a formula to calculate the Reynolds number. So how do we differ from each flow? So Reynolds number have a critical Reynolds number for the flow in a pipe. When the Reynolds number is lower than 2000, the flow is tend to be laminar. When the Reynolds number is between 2000 and 4000, the flow is transitional. And lastly, when the Reynolds number is larger than 4000, the flow is tend to be turbulent. Alright, these three flows have their own characteristic. The first one is for laminar flow. It is well-ordered and predictable motion of fluid particles with minimal energy loss and pressure drop. The second is turbulent flow. It is a chaotic and disordered motion of fluid particles with the formation of eddies and vortices with higher energy losses and pressure drop compared to laminar. And between those flow, it is a transitional flow where a mixture of laminar and turbulent flow with turbulence in the center of the pipe and laminar flow near the edges.
Before we get into the experiment part, here is a sneak peek of our discussion session before conducting the experiment.
Report writer. So sebabkan aku yang buat Gmeet ni kan, so aku jadi planner. And then experimenter. Siapa yang nak jadi experimenter?
Experimenter buat, lepas tu buat video kan? Okay.
Experimenter just explain objektif dengan buat eksperimen je. So, Atika boleh kan?
Yep.
So, Atika. So, untuk analis, dia just explain introduction dengan conclusion of the experiment. So, who want to be the analyst?
Disebabkan aku dah balik, aku rasa aku jadi analyst pun tak apa. So korang just send the data and biar aku buat introduction and conclusion lah for this experiment lah.
Okay.
Okay ke?
Boleh. So pula and then report writer, kita ada 5 orang. And then 3 dah ada role. So 2 lagi akan ambil report writer. So Dini dengan Nisa okay kan jadi report writer? Okay je, okay.
Dini okay tak?
Dengar tak suara?
Dengar.
Okay.
Dini okay kan? Jadi report writer dengan Nisa.
Okay.
So reparator ni macam senang je sebab kita kan dah ada introduction, objektif semua tu kan. So macam ambil je and then masukkan dalam report je. Tapi kena ikut rubrik dia lah kan. And then untuk eksperimen, korang rasa korang nak buat macam mana?
As a planner, macam mana? Ada cadangan ke?
Kalau ikutkan group-group lepas lah kan, sebab ada group yang dia buat different density, ada group yang dia buat berdasarkan volume je, and then kita just masukkan guna food coloring untuk kita tengok laminar flow and then transitional and turbulence. Kan ada idea lain?
Okay kat tu. Aku adalah tengok dekat YouTube. Dia buat macam mana lah. Dia based on time. Maksudnya dia buka air. Lepas tu dia ambil volume of water based on what you call fixed time lah.
So nak ambil yang mana?
Boleh, tapi yang kalau yang aku punya cara tu nak kena pakai measuring cylinder lah. Tapi kita tak ada kan.
Oh, kita tak ada measuring cylinder. So nak guna yang satu lagi tu, yang kita just guna container.
So kita fixkan volume, kita setkan time kan.
Senang sikit macam itu. Pakai je pelayar pelada. Memang fix lah volume dia.
Lisa dengan Dini okey lah?
Macam tu senang sikit.
Okey je, saya follow je.
Hello, my name is Siti Nur Atika binti Amilha. I'll be presenting the procedure for the experiment. The experiment was set up by: first, the transparent tube was connected to the tap water and 5.5 liter water container. Then, the syringe filled with rose syrup was injected into the transparent tube to indicate the flow pattern. The flow of running water from the tap was adjusted to a low rate until laminar flow indicated by rose syrup can be observed. Next, after the laminar flow has shown constantly, the transparent tube connection from 5.5 liter water container was changed to 1.5 liter water container. The time taken for the water to fill the 1.5 liter water container was recorded. 3 readings were recorded to obtain an average value. Then, steps 3 to 6 were repeated by replacing laminar flow to transitional flow and turbulent flow. All data was recorded and tabulated to make the calculations for the Reynolds number. Next, I provide the summary for the experiment that has been done in video. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdini binti Mokhtar, TJ211008. I will present the results that we obtained from the experiment. The inside diameter of the tube that we use is 0.009 meter. The area is 6.3617 times 10 to the power of -5 meter square. The density of the liquid that we use is 997 kg per meter cubic, and the constant volume is 0.0015 meter cubic. and the dynamic viscosity is 8.91 times 10 to the power of negative 4 kg per meter second. From the constant volume, which is 0.0015 meter cubic, we obtain 3 times for each flow and get the average from it. So this is the table of type of flow, which are laminar, transitional and turbulent flow, and with the time recorded. Based on data that obtained from the experiment, we have do some calculation to calculate the volume flow rate, velocity, and finally the Reynolds number. The Reynolds number for laminar flow is 927.41, the transitional flow is 3070.56, and finally the turbulent flow is 4154.17.
For the conclusion, there are 3 types of flow which are laminar, turbulent and transitional. The Reynolds number for laminar is not more than 2000, which is 927.41 obtained in this project. For turbulent flow, the Reynolds number is between 2000 to 4000, which is 3070.56. Lastly, for transitional flow, the Reynolds number is above 4000, which is 5154.17. As the purpose of this project is achieved, hence the project is successfully done.
That is all from our group. Thank you.